we're going to look at dividing fractions with other fractions. Now, it seems repetitive to say fractions with other fractions, but this is a great follow-up video to dividing fractions with whole numbers. Remember, fractions, when we have one that's not a mixed number, it's just like having part of a whole. That's really what a fraction is. Fractions are also mini division problems. So we got to start somewhere. Let's get an equation. Here's 4/5, and we're going to divide it by 2/3. So that's like saying within 4/5, how many 2/3 are there? That's really what that's asking. So first step, we need to find the reciprocal. Now, the cool part is you don't have to get a magnifying glass to find the reciprocal, but we do need to attend to precision. That reciprocal of 2/3 is 3/2, or 3/2. The reciprocal is when we flip it and the denominator becomes the numerator and the numerator becomes the denominator. I do this, and my next step now becomes the inverse operations. The inverse or opposite operation of division is multiplication. It's always going to be that. And you'll notice I'm still writing every single step out so I can double check my work. My next step is to rewrite it as 4/5, or 4/5, multiplied by 3/2, or 3/2. This should look really familiar. That's right, I'm just going to multiply straight across. In all of these problems that we do, I'm always looking for that, what's my next step? Do I know exactly what I'm going to do? Is there any opportunity for me to have a computational error? And if so, I'm not going to let that happen. I'm being responsible during math. So I multiply 4 and 3 to find the product of, that's 12, and 5 and 2 is 10. I could leave that as my answer. If this said simplify your answer, that's when I'm going to look at how I'm going to take this number of 12/10 and turn it into a mixed number. When my numerator is larger than my denominator, I know there's going to be a mixed number. Now, I already wrote to the right that I knew that would become 1 2/10, or 1 1/5, but how did I get there? That's a great pondering to have. Like I told you guys before, a fraction is like a mini division problem. So I divide 12 by 10, and I have 1 with a remainder of 2. But now I can look at these division problems in a whole new way. I know that the 1 that I have on top is a whole number. That whole number is telling me, yes, 10 can go into 12 one time by itself. My remainder is my numerator, and my 10 is my new denominator. Kind of had to abbreviate there because I write so big. So let's take a look at the next problem. Ooh, now this one is spicy because it has a mixed number. So 2 3/4 divided by 1 1/3. Now, what I really need to do is take this mixed number and turn it into an improper fraction. That improper fraction is going to give me a great springboard to finishing it out and making sure I follow through with the steps. So, how do I go from there? Well, I heard someone call this last year. I believe it was Dean called it around the world. We take our denominator and we multiply by the whole number, and then we add the numerator. But there is a reason for it. There's definitely not any guessing that goes into, well, where did this come from? So my answer would be 11/4. But let's look at a model that I'm going to make down here. I have pizzas that are cut into 4 slices. My denominator, remember, it tells me how many slices there are in this pizza. So there are 4 slices in each pizza. Now in these first 2 pizzas, I've taken all 4 slices and I'm coloring them in. So 1 2 3 4, 1 2 3 4. So that's 2 full pizzas. In this next pizza, I've only taken 3 slices. So if I add up all the slices that I have, I get 4 plus 4 plus 3, and I get 11. And guess what? That's the same answer that I got for when I went around the world and multiplied my denominator, my whole number. Oops. And I added my numerator. Some technical difficulties on that. So I rewrite the problem as 11 over 4 divided by 4 over 3. So let's get to that next step. I need to find the inverse. And I'm only finding the inverse operation of the second fraction. I'm not doing both. Then I would just have the same exact number. It's not how this happens. So it's 11 over 4 divided by 3/4. I find the inverse operation. The inverse operation in this case is multiplication. So it turns into 11 over 4 multiplied by 3/4. It should be familiar at this point where my next step, my only option, is to multiply straight across at this point. So I'm going to multiply 11 and 3, that's 33, and 4 and 4 is 16. Now I'm going to use long division to simplify because I'm feeling pretty confident. So 33 divided by 16. I know 16 can go in there 2 times because that equals 32. When I subtract it, I have 1 left over. The 2 is my whole number. The 1, that's a remainder. We talked about that earlier. When I have a remainder, I could write remainder 1, or I can write it as a fraction and be really powerful and write 2 and 1/16. Pretty cool, huh? I love seeing all these pieces come together when we work hard in math, and it's awesome to feel like you totally understand and got a handle on it. Thanks for joining me.